This part of the story is about the relationship between the electric field and the electric force. Now, you've heard of forces before, maybe not the electric force, but forces in general were interactions with external objects that have the potential to change my state of motion. So, in this case, we want to talk about something called the electric force, and we want to relate it to the electric field because we've talked a lot about how to calculate the electric field in multiple ways. And we want to find out how to think about the electric force. Now, the electric field, as you've seen, is the influence of charges at some location in space. There isn't necessarily a charge sitting there. I'm just identifying the influence of a bunch of charges. Maybe it's a distribution of charges like a ring, or maybe it's a linear thing, or maybe it's a sheet or a volume thing. Distribution of some charges creating some electric field at some location in space. And then the electric force, though, is about the interaction between charges. So I need multiple charges to interact. The analogy to gravity is that the gravitational field, or as we called it in physics 1, the acceleration due to gravity, that's a gravitational field that the influence. So if I'm thinking about, for example, on the surface of Earth or near the surface of Earth, then I would say that the gravitational field is created by Earth. So we call that little g, and it's 9.8 meter per second squared downwards. Now, if I put another mass there, that mass will experience the force, and that force is simply just the product of the mass experiencing the force times the gravitational field. In this story, though, we want to talk about electric field and electric force. So we're going to be talking about charges that are sitting inside an electric field. So the setup is that there's an electric field that is generated by somebody else. And then I have a charge Q naught that is sitting in that field. And I want to ask myself, what is the force experienced by that charge? So similar to gravity, the electric force is just the product of the electric charge and the electric field. So it's a scaling of the electric field by the charge. So that gives me two possibilities, because as opposed to gravity, where we only have positive masses as far as we know, for electric charges, there are positive kinds and negative kinds. So potentially I can have a positive charge sitting in an electric field, in which case I can think about the force as being in the same direction as the electric field, because this is a positive charge multiplied by the electric field. It's a positive scaling of that vector, so it gives me a vector in the same direction as the electric field. So we say positive charges experience forces in the direction of the local field. Negative charges, on the other hand, we don't really have negative masses as far as we know, but you could kind of simulate a negative mass by saying it's the absence of mass in a sense. So you could think of a bubble in a fluid, for example. And you say, if I put a fluid in a gravitational field and I look at the motion of the bubbles inside that gravitational field, it implies that there is a force in the opposite direction of the gravitational field. If the gravitational field is down, the bubbles bubble up. So in this case, if I put a negative charge in an electric field, it experiences a force in the opposite direction of that field. In both cases, the magnitude of the force is just the product of the charge in the field. But here, because I have positive and negative charges, I can have forces that are in the direction of the field or in the opposite direction of the field.